Welcome to Study Loop.
For this question, we are given a reaction, CoCl2 in equilibrium with CO and Cl2, its equilibrium constant, and a series of three different initial conditions, and we are asked to assess whether these conditions are at equilibrium, and if they're not, what direction the reaction needs to go to get at equilibrium. This is a roundabout way of asking us to calculate Q, which is the reaction quotient for the given conditions. And remember that it's calculated like K is, so it's products over reactants. And so we're just going to go through here and plug in the values that were given for each of these three conditions. For A, this is 3.3 times 10 to the minus 6 times 6.62 times 10 to the minus 6 over 2 times 10 to the minus 3. If you do that math, you get something on the order of 10 to the minus 8. So you'll notice here that your Q value, being 10 to the minus 8, is greater than your Kc value, which is times 10 to the minus 10. Therefore, we have more products and fewer reactants. So to get to equilibrium, we would need to shift to our reactants. The same procedure applies to the other two problems. We calculate the Q the same way as above. Plugging in the numbers that the problem gave us. And this time, we get something times 10 to the minus 12. So here, Q is less than Kc. That means our ratio of products over reactants is smaller than it should be. And so we need a shift to products. We'll do this procedure one more time for part C. We have the same concentration of both species on the product side. And 0.01 of our CoCl2. And here we see to the three significant figures that are appropriate, Q is equal to Kc. And as we've seen previously, this is what happens when we are at equilibrium. So the reaction does not need to shift in either direction.